Hey everybody, look what Santa just brought to my house. Love when packages come from Tempe. So today being the day after Christmas, I thought we'd open up a package and see what we got. So let's do that. What could it be? Kind of feels like a $100 bill. Hope everybody had a good Christmas or Kwanzaa, Hanukkah, whatever you celebrate or don't celebrate. Don't need to celebrate anything if you don't want to. But I'm celebrating. Ooh, look at that. Oh, 12AY7. Can you see that? That's going to go with this guy here. The amplifier we're going to be working on in this video. Oh, this is also needed for the amplifier in this video. We have our electrolytic cap. I don't know, it kind of seems the same size as the one that didn't fit. Might have to go to Plan C, but we'll figure it out. There she is. You see that? Let's see what else we got. A bag of goodies. Basically, I think it's just going to be capacitors, and more capacitors. Oh, and some knobs. What the heck did I get knobs for? Probably for the Vega. Probably needed to spend some more money to get that free shipping. But, got a bunch of capacitors. And a lot of these are for the weirdest amp Rachel ever played. SG system SG212. So that'll be in an upcoming video. And we got a nice little handle for our Vega amp. Looking pretty. And here's the screws. I don't know if you can see that. No, I definitely can't see it in the bag. What's this big giant gray hair coming from?
Gandalf. Yes.
Definitely not me. Must be from Mrs. Claus. Can you see that? Probably not. But it's a finished screw. I think that'll look nicer when we drill out the rivets for the old handle and install the new handle. We'll put these nice looking finished screws on there, and it'll look a little nicer than a couple of Phillips heads. So there you have it. Wow. Does not take much to spend $89 at Antique Electronics for amplified parts. But yikes, where does it all go? Alright, anyway, let's build. I'm sorry, we're not building, we're repairing, so let's repair. I'm doing a little studying here, and as discussed in the previous video from that article with the links in the description here, the schematic for this amp is non-existent, but we believe it is very similar to a Harmony H204 or possibly a Electrolab R500. And I'm comparing the two schematics here. And here, I have a screenshot. I have another screenshot. So I'm comparing the two of them here, and the preamps look very similar. But once you get over past the phase inversion, it seems to be a little bit different, but it's kind of hard to tell on a cursory inspection because the drawings are drawn differently in different styles. But it seems like there are some differences, but I'm going to scrutinize that some more. And I'm going to see what's in the amp, but that's no guarantee either because, you know, there was some previous work done to the amp, so who knows what state it's in and what's original and what is not. But also the power section, this is from the Harmony schematic. We have 4 sections. And, well, not 4 sections, 3 sections with 4 filter caps here. They're calling for 335, 243, and 138 volts off your 3 filtering nodes. This guy is super low voltage. Where are we here? If I can find it, here we are. It doesn't say right there, but I saw voltages earlier. All right, 305 to the plates. So, oh yeah, 315 going to your center tap. All right, and then if we look at the voltages on the plates of the preamp tubes, we've got 135 there and 50 volts there. Really? 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 Yikes. And as we know, our transformer is kicking out 430 volts. So yeah, I'm not sure what to do about that, but we'll do something. We'll consult our RCA receiving tube manual. We'll see what the 12AY7s want nominally, and we'll see what we get. If it's in spec, if we're not going to blow the thing up in a blaze of glory, and maybe make adjustments to the dropping resistors. But we're a long way from that. So let's get the chassis over here. Let's come up with a plan, Stan, and let's take that hill. All right, we're giving the amp a little cleanup before we get started here. She is a little bit grubby. And we're enjoying a delicious cup of coffee. Nice Ethiopian bean. I want to give a very Merry Christmas shout out to all our Coptic friends. They sure know how to grow a nice coffee bean, let me tell you what. But, oh yeah, look at that, that's better. Wow, this thing is grubby. Look at that sparkle. I sent all this dust to the lab. I think Jimmy Hoffa was buried in here at one point. Yikes. I'm just using a store brand bum wiper. Yeah, that looks a little bit better. Yeah. All right. All right. Here she be. Yummy. Look at that. Okie doke. Let's go into the hood and start tearing her apart. Okay, so first thing we're going to do is get this power cable out of the way. Get this out of here. Let me turn Mr. Soldering Iron on. As you can see, it's wrapped around the fuse holder in a knot. Because, why wouldn't it be? But it's just in the way while you're working on an amp, and I usually like to put these things in last. But let's look at the quality work that the previous tech did. Now, I'm not claiming to be a great amplifier technician. A lot of the guys on YouTube, like a couple guys that are in the description, and others that are very popular, they have like, some of them have like 20, 30, 40 years experience. And I've got about 30 or 40 minutes worth of experience. But the place that the previous owner of this amp bought it from was it's a place that's no longer in existence, but it was a, very reputable store up here in the greater New England area. And they had their guy put the 3 conductor cable on there and service it, supposedly, so the story goes. And yeah, I would have expected something better than this. Can you see that? Wrapped in fucking electrical tape, among other things. But whatever, we can't all be perfect. It is what it is. I guess that makes me the next generation of amplifier technician, which is well, Well, it's going to be a dying art and science because I'm over the hill. And what exactly were we wrapping up there, guys? Anyway. Alright. Snippers, if you're getting into this, spend the money on a decent pair of snippers. With like hardened steel, don't get the Harbor Freight ones. No substitute. Yikes, this is ridiculous. Snip! Briss!
Hello, Dr. Schwartz. Thank you so much for coming all this way to perform Ike's Briss.
Oh, my pleasure, Sheila. I brought the normal cutting device. But then I remembered that Ike was Canadian, so I brought the right one.
Let's see here. I totally want to do this, because this is a, Vega was a Swedish, founded by a Swedish gentleman. I totally want to do this like the Swedish chef from the Muppets. It's a good amplifier. Not that I can do a good Swedish accent. Oh wait, is Johan Sageborn, is he Swedish?
Hi,
Oh, we can have some fun with that.
and it is probably the most influential rock and roll amp of all times.
All right, let's go.
Okay, let's go.
Ow, that's hot.
That's hot.
Thank you, Paris Hilton. Out you go. Oh, you should probably remove the fuse before you solder on the fuse holder. The way a fuse blows is it overheats. And, yeah, soldering iron hot, so.
This is really hot.
May or may not be a thing, but I don't know, probably is a thing. But whatever. The deed is done. Look at this. This is ridiculous. Be gone. Alright, let's get that fuse out of here. See what they put in there. I did not check this yet. Which is a grave cardinal sin. Alright, what do we got? I'm thinking it should be like a 1.5. I don't think it says on the chassis. 110, 117 volts, 60 cycles, input 75 watts. Could probably do some Ohm's law and figure out what would be appropriate, but it's a bus fuse. And is that 3 amp? 3AB2. Yeah. Well, I don't know what 3AB2 means, but I imagine the 3A is 3 amps, which is inappropriate. So that's gotta go. Ugh. They fucking butchered this thing. Alright, so, now what I'm going to do is, I got this photograph from that website article. I'm going to compare that with this schematic, with what's left in here, and see if I can't decipher how this circuit was designed originally. And we're basically just going to rebuild it from scratch, because there's no hope left.
Abandon all hope, ye who enter here.
There's no hope. Everything must go. I'm gonna have a blowout sale. Everything must go. And we'll start from scratch. I don't see anything worth saving in here. I mean, maybe those ceramic capacitors, this little, yeah, whatever. Yeah, it's all gotta go. And those carbon comp resistors, I mean, what is this, a 57? So do the math. It's like a 600-year-old amplifier, 600-year-old carbon composition resistors. We got electrolytic capacitors that look like mummy fingers. Everything must go. So we're going to rewire a hand-wired point-to-point amp. So how fun is that, right? So yeah, here we go. All right, so this weird guy right here, turns out it's just a 33K resistor. We test them. Measuring 35, but that's actually still pretty good. But yeah, orange. I was just unfamiliar with that, the look of that one there. But they have that as a screen resistor, and it's coming off the second node into this terminal here that doesn't go to anything on the tube itself, so they're just using that for connections. And we have that brown wire is bringing voltage in from the second node, I believe. Or where's it coming from? Well, it's coming from somewhere. It's coming off the power supply. We'll sort that out later. And then it's connecting to the 33K resistor here. And then it's tied into the screen here, which is in parallel with the other screen of your other power tube. But if we look at our schematic, it does not call for any screen resistors. But yeah, we like screen resistors. The photograph of the amplifier online has the same exact thing. So that looks to be original. Fender uses a 470 ohm screen resistor, as you can see right there. And that's from an AA763 Deluxe. But we're not going to reinvent the wheel. We're going to try and put this back as factory as possible. So we'll probably just use a 33K. See what happens. We'll start from factory and we'll take it from there. Alright, so trying to figure out the inner mysteries of this thing, and it's just kind of bizarre, some of the things that they do here. So let me get the real Mr. Pointer here. This brown wire connects to your high tension. So you got high voltage coming in, and then right here it gives high voltage to your screen. Okay. And then if we follow, it's also connected to the screen of this other power tube. Then it goes through this 33K resistor to a pin on the tube socket that has no contact to the actual vacuum tube itself. It's just being used as a terminal to connect stuff. And then if we follow this brown wire, it goes over to here on this weird socket thing. A tube doesn't go into this socket. It's just it's a tube socket with a little base with some holes in it, and the only thing the base is doing is jumpering this terminal to this terminal. But anyway, so we're coming off of the screens and we're going to here, which goes nowhere, does nothing. The only thing I can think of is maybe they're using that as a test point, so you don't have to open up the chassis. Because why? Why build a highway to nowhere?
Faster.
So anyway, I'm figuring out this socket. Here's a drawing. This is what I've deciphered so far. They're using pin 7 and pin 1 to route your heaters to your pilot light, and then reroute heaters to other places as well. Okay, good. And then that's the brown wire we just talked about, goes to nowhere. And also using pins 4 and 5 have a jumper on the underside of this in the little base that's stuck in there. And we can see pin 4 is just a bus wire going to ground. And then this white wire is basically this guy right here provides the ground for the grid, and this guy right here, the ground for the grid, because it goes to this terminal here, which is bused underneath, and then comes out here through this bus wire and goes to ground via this tube socket. Just a real roundabout way of doing things, but whatever. And found a difference from the Harmony schematic. Harmony calls for 470K. What was installed is 560K in this amplifier here, as well as right here as well. So we're going to use the 560. Alrighty, moving on. Here's a shot of that thing from the other side of the chassis for reference. As you can see, pins 4 and 5 are jumpered together on this end, and that's going to ground, those two connections. Alright. Okay, so I'm scoping out the preamp section going to V1 from the input jacks here. And the wiring is very similar to what you see here, up to the tube. Confirmed that we have our 39Ks right on the jacks. This guy is not a 10 meg, it's a 4.7 I believe, but I measured it in circuit, but it should be an accurate measurement, but if that changes, I'll let you know. We don't have 220s here, we have 0.25 meg, which is 250K there, and then 0.01 here, and here. So the 0.01s are those red guys there, and then these other guys here are 0.004, those yellow looking wax ones there, which would be that guy right there. So so far so good. I think there's hope for this one. But so we sort of did this end, we did this end, and we just got to verify the middle and the tone stack, and then sort this mess out. So wish me luck. Pulled this guy out of the chassis and threw him on the meters, the multimeter, the ESR meter, and she's perfect. Absolutely perfect. So we'll throw her back in the parts bin, and we'll use her hopefully someday in another amplifier. So there you go. Recycle, reuse, refurbish, reject. Okay. I threw the new can capacitor in there, and it wasn't a perfect fit. The problem was with this bracket, this space under here for where the lip should be. The lip on a modern can is just too big to fit under there. But we made her work. She's not going anywhere. It's nice and tight in there. And if this wasn't, you know, a unique and like a very old Tweed era amp, I would have drilled out the bracket, and I probably would have gotten rid of this guy because I believe it's superfluous. And since the power transformer is over here, it would have been better to have your filtering right next to it instead of sending, you know, wires all the way down here for your filtering. That kind of doesn't make any sense, but whatever. It is what it is. But so far we haven't drilled any holes, and hopefully we'll keep it that way. Moving on. I have found a significant change from our Harmony schematic here. And if you watched the last video, you may recall I was talking about these, you know, shock absorber springs here, and this capacitor was going places that made no sense. But I think I was mistaken what pins it was on, because it was just very difficult to see. And they have the two heater terminals kind of bent together, so I didn't notice it was two pins, two lugs there. Looked like one, so when I was counting backwards or forwards or whatever, it was screwing me up. But anyway, we got to the bottom of it. Here's what's going on. So, if we, the tone stack here on this schematic does not exist in our amplifier. What is going on here is we're coming out of the sweepers of our two volume knobs. Alright, and then we're going to go to this drawing here. So here's our two volume knobs, right here, volume knob here, volume knob here. And each of those coming out of the sweeper goes through a 250K resistor. And you can see that here. Got a 250K and a 250K here coming out of the sweepers. And then we're going to another node here. So this basically right here is the node that I'm talking about. And we have this 0.004 microfarad capacitor and another 250K resistor. And the capacitor goes to one end of the tone knob. The resistor goes to the other end of the tone knob. And then connected to the second end is another 0.004 microfarad capacitor, and that's going to ground. The other end's going to ground. And out of the sweeper here of the tone knob, we're going into the grid of V2. So pin 2, V2 pin 2. Coming out of the sweeper of the tone knob. So that's this green shielded wire going into the grid. And then that gets us here. And that's where we're at. So we're almost done. Just need to check a few more things, and then we can start getting our hands dirty. Pulled out this big orange capacitor here. This was the one that had the shock absorber springs on it, and as soon as I hit the legs with the soldering iron, that thing uncoiled like a slinky.
It's slinky, for fun it's a wonderful toy. It's slinky, it's fun for a girl and a boy.
Never seen anything like that before, but again, I haven't been doing this that long. I'm basically the Jon Snow of amplifier technicians.
I could teach you how to do it.
I know how to do it.
You know nothing.
But anyway, there she is. Kind of neat. Okay, little progress update. Got V1 pretty much all sorted out. Got the 4 new capacitors there. The 250K and the 4.7 megs were all reading good. So we're leaving them in there. So we just need to double check our work. Make sure nothing's bridging anything else. And then we'll move on to the next spot. And also replace the capacitors on the tone stack. So that should be all sorted out. So then we're going to move on to V2. And the power supply and everything else. Yeah. Still got a ways to go.
3 weeks later.
We are back. Hello everybody. It's been a couple of weeks. No, it hasn't. It's been a week since you saw that last clip. Or no, it hasn't. I have no idea what I'm saying. It's been a week since what you saw in the last clip transpired. I don't know. Whatever. Happy New Year, everybody. Let me be one in a long line of people to wish you a Happy New Year. Hopefully you have a long line of people wishing you a Happy New Year. If you don't, then you're probably like me. A lonely eccentric. Stays cooped up in his house, playing with wires. I imagine my neighbors think I'm building bombs. But anyway, Happy New Year. Here we are with our buddy, the Vega Director. The Vega Instrument Company from Boston, Mass. Quite possibly the greatest instrument maker of all time. Jury's still out on that. So what are we going to talk about today? What are we going to do today? I read that article again, link in the thing. This time I paid attention. Yeah, probably not a Velco. Probably a Electrolab. If this were a Velco, the cabinet would probably be nicer. But regardless, probably Electrolab, also a Chicago company, which, Chicago speakers. Surprised it didn't come with a free deep dish pizza. But there's that. So over the week, I did a little bit of work, got her fired up and working, which is kind of a miracle. Because there was a bunch of guesswork involved, or educated guesswork. And by educated, that term is definitely relative.
You could learn a lot from a dummy.
But, yeah. Anyway, so, what are we going to do today? We're going to bias it for sure. I'll show you all the crap I did. A couple of thoughts for the future. We need to replace those guys right there with nice new ones. Or we may not need to, but we're going to. And then, yeah, we'll just take it one step at a time. So if that sounds interesting to you, and I'm not sure why it would, but if it does, hang tight. Here we go. Boston, baby. Yeah. All right, so let me give you the Sports Center highlight of what has gone on in here, and here. So, as discussed previously, pardon me, the circuit is very, very, very similar to a Harmony H204. When I received this amplifier, there was work done on it, but it looks like they did not touch any of the resistors. They just replaced some capacitors. So if you want to take a look at this, you can see all the changes to the differences between what was in our Vega and how it was different than the Harmony. And so these are all the changes, blah, 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 in red. I'm not going to go through every single one of them. But the biggest change was the tone knob was not at this location.
You're repeating yourself, you know that? You're repeating yourself.
You're repeating yourself. You're repeating yourself.
And then the power supply just had 3 nodes off a can cap instead of all this mess. And we replaced the can cap, and he's down there. Can't really see him. Another little bit of weirdness after I got this all up and running is the voltages have gone down significantly. At this point, right here, the measured DC voltage is 335 volts, which is bang on to what the schematic calls for, which is weird because we were at 430. I can't imagine, you know, the original Sylvania 5Y3 was banging out an extra 100 volts. But whatever, it is what it is. So this is what we have right now with our 3 nodes. And since we're down to a modest 335 volts, you know what that means? Black tubes, baby. Gotta love them. They're dirt cheap, relatively speaking. They're indestructible. They sound great. You can do that. So, yeah, there you go. The last little bit of fun was, as I said before, the schematic was basically almost exactly the same, other than the tone knob from the Harmony H204 to the Vega A60 Director we have here. As far as I could tell, until I got to V2. Now this is where the previous tech did the most changes, and once I started removing components, there was a bunch of cold solders and it basically crumbled in my lap. So I could not see how he originally had it wired up. So basically what I did is just, I just copied what they had for V2. And I used the values of the resistors that were in the amplifier. Pardon me. Because the resistors appeared to be original. So this is what we have. And I'm not the greatest point-to-point wirer as far as, you know, efficiently sticking components to make the simplest layout. But I basically just did a, you know, a literal translation of this onto all the junk in there. But with all that said, I fired her up, and once you know it, she works. She sounds pretty darn good. So I'd rather be lucky than good any day of the week. So where we're at now was the amplifier calls for two 12AY7s, two 636s, and a 5Y3. Was playing around with these tubes a little bit because the amp was a little quiet. So I was tried a 12AX7 here, then I tried one over here, and then I tried them both. And yeah, the 7025/12AX7s actually sound awesome in this amplifier with two 12AX7s and you know, the 2 channels jumpered and the volume knobs both all the way up. It's just right on the edge of that nice greasiness, and it's like perfect. So I think we're gonna let this ride for now and see how she does. Again, I'm going to be doing the cosmetic stuff in the spring, so we got a couple of months to play around with this amplifier and have some fun. So we'll go with that. The original tubes that came with the amp, they're modern Softex. And so the final thing we're doing right now is, the last thing, this input jack was intermittent. It had a cold solder on it, so we fixed that. And lastly, but most importantly, we're biasing the amp right now. Let me get my bias sheet. With the metal tubes, we're at a measly 7.2 watts of plate dissipation. It is on the current limiter, so we're probably around 8. So we're going to replace the bias resistor, which we already did. I don't know if that's going to be big enough. That's the closest one to what I think we need. I was hoping to find like a 180 or a 200 ohm because it had a 240 in there, but that's what we got. We're going to fire her up, check the bias, and see how close we are. So wish me luck. So I just checked the bias with the new bias resistor, and it only went up to 8.6 watts of plate dissipation, which, I don't know, it doesn't seem right to me. So we're going to throw it on the, this guy here, what's it called, the tube checker. Term escapes my mind. We're going to check the plate current through a multimeter. Yeah, look at that. Who doesn't love a black tube? Yeah, other reasons we love black tubes is they look cool and they're super old. And we like old things around here. But in order to get this to fit, I'm going to have to crane this up on a winch or something to get it a little higher off the table. So, yeah, this isn't sketchy at all. Not one bit. There you have it. 0.0278 amperes. And the original calculated was 0.0263, so I get around 0.028. You know, it's steadying out around 0.0277. So yeah, it's pretty close, measured and calculated. So okay, we're gonna have to go down a little bit more on that bias resistor. I think I have an 80 in the box, so we'll try that. All right, so this is where we landed. The smallest resistor I have, 5-watt resistor, is 100 ohms. And that's given us that. And that calculates to 9.4 watts of plate dissipation. But we got to remember this is on the current limiter. So that's going to go up a little bit. So, yeah, we'll play around with it right here for now. And we'll make some decisions about what we want to do later. I mean, why do now what you can do later, right? Okie doke.
Well, boss, I'm back from my vacation.
You didn't happen to run into your brains while you were out there, did you?
No, but I wasn't really looking.
All right, now the last couple of things we're going to do before we button her up and take her for another test drive is probably throw a bypass cap on there. And then there is a little bit of hum. It's probably coming from the heaters. There is no center tap, and there is no virtual center tap. So we'll probably, on this guy here, we'll throw a couple of 100 ohm resistors to ground and see if that helps our little bit of hum. And then we'll button her up, take her for a test drive. While I'm thinking about it, if you have an amplifier like this where the chassis is in two parts and you got a cover and then a bottom part, the way that the input jacks are grounded are by the connection of the jacks to the chassis themselves, the physical connection. There's no wires for the ground. So when you have the lid removed from the main part of the chassis, you need to add a little jumper or something like that so there's a reference to ground. And otherwise it will not work. Ask me how I know. Alrighty folks, we got her dialed up to $1.20. Here's the readings. Take that with a grain of salt because we're still on the current limiter. I don't know if you can hear this. Still got a little bit of hum. So the virtual center tap did not solve that. But I think we're going to have to go back in there at some point and twist the heater wires and redo the whole heater wire setup because they're just laying flat on the chassis and they're not twisted at all. But here she is. Let's take her for a test drive. All right, this is with the two 12AY7s in the preamps, and I think we like the 12AX7s better, but you be the judge. Let's pop a AX7 in V1, see what we get. Alright, we got a modern Sovtech 7025 in V1. Let's check her out. Tweedy goodness right there. It's getting better, but I think the article that we read about this amplifier and also the way we purchased it had the right idea with AX7s in both positions, so let's do that. Alright, now we got the two AX7s warming up, and I just want to do a really brief demo because the way this is situated, the two metal 6v6s are right underneath the output transformer, and those suckers are HOT hot.
That's really hot.
So, yeah. I don't know how it sounds on the camera, but sounds great. It's not very loud. This is definitely would be a great bedroom amplifier. But mic'd up, oh boy, this sucker's gonna sound awesome. So, yeah. quick before we melt the output transformer. Let's take it to 11. So if we turn this guy down, this is just the microphone input.
Took me a while to figure that one out.
Well, there you have it. How cool is this little amp? Sounds amazing, even, you know, backwards and stuff, and not completely finished yet. She sounds great. She's definitely got that Tweedy character, and I think Alnico speakers are probably definitely my new favorite thing. So we just got a couple of things left to do on this guy before we call it quits, so there will be more videos. Gonna rewire the heaters for sure. We'll try and eliminate and eliminate as much of the hum and noise as we can. I think that's the main source of it, the way it's wired now from the factory. And we need to clean up the cabinet, fix the little peelage problem over here. But she sounds great, and I'm definitely going to do a Let's Record video this weekend, if I can find a song that I can actually play all the way through. But, you know, it's a long weekend. Don't have to go back to the silly day job until Monday. Fuck this Honda Civic.
Yeah, fuck your Honda Civic.
Fuck this Subaru.
Fuck your Subaru.
Definitely fuck this Mitsubishi.
Fuck your Mitsubishi. I have a horse outside. If you're looking for a ride, I have a horse.
So, yeah, there should be plenty of time to do that. And, yeah, that'll be great. So, Happy New Year, happy New Year, everybody. Here's to 2021. And, keep on rocking in the free world.
Done.
Did I say 2021? I really am a tool. Happy 2022.
Get it up, get it up, get it up, get it up, yeah.